This video is going to be about solving quadratic equations using the quadratic formula. Now, the great thing about the quadratic formula is that your coefficients and constant in your quadratic equation could be any real number at all. They don't have to be real clean in order for this formula to work out fairly easily, okay? Some of the other methods that we use for solving quadratics require certain things like, solving by factoring is very restrictive because you have to have a quadratic expression that will actually factor, okay? Whereas this method for solving a quadratic equation is actually very, very versatile. Now, the quadratic formula itself is kind of weird looking, okay? And all of you have already seen it and used it before in algebra classes, but some people have a hard time memorizing it, which you do need to do for the test, okay? So let's take a look at the formula itself. Well, first of all, let's write this down again. Ax squared plus bx plus c equals 0. Okay, this is the general form for a quadratic equation, and in order to use the quadratic formula you have to know the values for a, b, and c. Okay, so you really need the equation to be in this form. You need that general form with 0 on one side before you can use the quadratic formula. Okay, now this is how the quadratic formula goes. Your x is going to be equal to negative b plus or minus the square root of b squared minus 4ac, all of that under the root, notice, okay? And then that whole thing is over 2a, okay? And what I want you to pay close attention here is that the whole top is over 2a, okay? I've seen a lot of people make the mistake of bringing that negative b out in front of a fraction, and it's not. It's in the numerator of this fraction along with that square root. Now, you could split this up into two pieces. You could do negative b over 2a plus or minus, and then do the square root that you see there over 2a. But you'll usually see it written like this, and one thing that will help you memorize this if you don't know it already, there are a lot of different videos that you can look up on YouTube. Just type in quadratic formula song, and you'll get a whole bunch of different ones that'll pop up. That's how I memorized it when I was in high school. That's how a lot of people memorize it. We sang it to the tune of Pop Goes the Weasel, okay? And my voice is terrible, but I'm going to sing it for you in hopes that maybe that'll help you out. It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And since Pop Goes the Weasel is something that most people know from when they were a little kid, that's a pretty easy way to remember it, okay? And they would just make us sing it over and over in the classroom. I'm not going to make y'all do that in class. Don't worry about it, okay? Because there are a lot of different little melodies and tunes that are out there on the web that you might like even better, okay? But I know that that's what's helped me. In fact, I sing it in my head every single time I ever write it down. And I have just always used that, okay? So find a little catchy tune that you like to kind of help you memorize that. And like I said, you can look up a whole ton of them on YouTube. There are bunches and bunches of them on YouTube. Alright, let's try this out in an example. What we do when we work through the quadratic formulas, we're going to take a, b, and c and plug those in where b and a and c are in the formula. And then we are going to simplify it as much as we can. Starting with what's under the root, we'll square b and we'll multiply 4 times a times c. We'll do that difference. If we do happen to wind up with a negative value under the root, that will become an imaginary number, and we'll use that, okay? So let's give it a try. Let me get a new page for us here. I think that'll be a little cleaner than... All right, here we go. Here's our example. Let's take... while I'm paused for a second, let me find my little stylus. It's easier to write than with my finger. Let's solve the equation 4x squared minus 2x plus 3, okay, equals 0. Now, quadratic formula can be used in cases where you could factor if you wanted to, okay? I don't think we can factor this one, but we may find out differently as we work through. What happens if you happen to have a problem that could have been factored? Then your solutions will turn out to be rational, okay? If your solutions are irrational, then you know that you did have an equation to begin with that you could not have factored by normal factoring methods. All right, let's give this a try. What I like to do first is go ahead and write down what A, B, and C are. That just gives me a nice visual reference for those, and I don't have to keep coming back to the formula or the equation to find them. So A is 4, B is -2, and C is 3, okay? And then I'm also going to come over here and go ahead and write that x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And y'all can all laugh at me singing that. That's fine. I don't care, because it's really, because I know it's bad. But if it helps anybody, it'll be worth y'all laughing at me, okay? So here's what we're going to do. We're going to take b first. Now, b is a -2. And let me scoot up just a little bit so we got some room. B is already negative. So when we plug that in, that negative and the negative that's already on the b are going to turn into a positive. So that is going to give us x equals +2 plus or minus the square root of b squared, okay? So I don't always write all this down, but what would we get from squaring -2, okay? And that's going to turn out to be a 4 in just a minute, right? And then -4 times 4, that's A, times 3, which is C, all over 2 times A, which you can go ahead and multiply that out too. So do as much of that as you can do in your head as you're writing it down, and that will speed your process up just a little bit, keep you from having to write quite so many steps. Alright, so from there, and I'm going to continue to put that X so that I don't forget it's there as we go on and on. So on top we've got 2 plus or minus the square root of 4, -2 squared. And then I'm subtracting from that 4 times 4 times 3. So let's see. That's going to give me -16 times 3 is -48. All over 2 times 4, which is 8. We've got a lot of 2's here, notice. We looks like we're probably going to be able to reduce the fraction once we get done by a common factor of 2. Scoot up again. X is equal to, if you're hearing squeaking, my stylus keeps squeaking on the screen, so I don't know if that's going to be recorded in the microphone or not, but if you hear a weird squeak, that's what's going on. I apologize for that. I'm not really sure why it's making that noise. 2 plus or minus the square root of 4 minus 48 is going to give me a -44 all over 8. And as I said, if you got a negative under the root, that does give you an imaginary number. And so our, our x is going to be equal to 2 plus or minus the square root. I'll tell you what, let's go ahead and bring that I out, okay? That's the negative that I take out as an I, imaginary number, and I'll go ahead and split 44 up as 4 times 11. I do need to take any perfect square factors of what's under the root and do the square root of those factors to bring them out. That is how we simplify our radical. So x is equal to 2 plus or minus, square root of 4 is 2, I, on the square root of 11 over 8. Okay, now at this point you've got a couple of different ways you could go. If it's real, you don't have to split this up into 2 fractions. You can leave it all as one piece, but you do need to reduce it if you can. And notice, like I said, we do have a common factor of 2 in the 2 terms that are on top, and of course 8 shares a factor of 2 also, so we'll be able to reduce that. If it is imaginary like what we have here, you do need to write it in standard form, like we talked about when we were looking at complex numbers a couple of sections ago. The complex numbers have a standard form where the real part's first and the imaginary part's second. So what I'm going to do, because this is just how I like to do imaginary numbers that have this particular form where they're in a fraction with a couple of terms on top, I'm going to go ahead and split that fraction up. And if you want to, you can reduce as you split it, that's fine. And then I'm going to reduce the two pieces separately, okay? So x is equal to 1/4 plus or minus I square root of 11 over 4. Okay, so that gives you a feel for what you do with the quadratic formula. It'll work, as I said, for any quadratic. So a lot of people will take the quadratics that are done by other methods that they don't necessarily like, or maybe you're not quite as good at as they might be the quadratic formula, and they'll either double check or just do those problems with the quadratic formula instead. In fact, I've had people who are not really great at factoring, and they'll just use the quadratic formula for all of their quadratic equations. That does cause trouble in some instances where you do need to factor. It depends on the problem. If you're just sort of solving the quadratic equation, then it really doesn't make any difference. But if you were doing something with the factors of a quadratic rather than the solutions, then it might be a little tricky to do it this way. Okay? So if you have any questions, let me know, but look over some of your homework problems, apply what you've seen here in the video to some of the problems that are in your homework, and let me know in class if you need anything.